Awesome. Thank you. Thank you so much for attending this talk about architecture for flow with Wardley Mapping, domain-driven design, and team topologies. Malheureusement, je ne parle pas français très bien, so that is the reason. That is the reason I have to switch to English. So most initiatives that try to optimize or change a system are usually directed at improving parts taken separately. They tend to focus on a local optimization of the separate parts of the system. But from a system thinking lens, local optimization of separate parts will not improve the performance of the whole. Dr. Russell Eckhoff, one of the pioneers of the system thinking movement, stated that a system is more than the sum of its parts. It's a product of their interactions. The way parts fit together determines the performance of a system, not on how they perform taken separately. He also claims that if the systemic nature of a system or organization is ignored, their efforts of improving or changing that systems are doomed to failure. So, when building systems in general, we are facing the challenges between building the right thing and also building the thing right. Building the right thing addresses effectiveness and addresses questions: how aligned are our solutions to our users and business needs? Are we creating value for our customers? Have we understood the problem, and do we share a common understanding? Building the thing right, on the other hand, focuses on efficiency and how efficient are our software engineering practices. And it's not only crucial to generate value, but also being able to deliver that value to our customers. And how fast can we deliver changes? And how fast and easy can we make a change effective and adapt to new circumstances? So the one does not go without the other. But as Dr. Russell Eckhoff pointed out, doing the wrong thing right is not nearly as good as doing the right thing wrong. So by considering the whole and having effectiveness and efficiency in mind to build the right thing right, we need to have a holistic perspective to build adaptive systems. And one approach that I would like to share with you today is combining the perspectives of business strategy with Wardley Mapping, software architecture and design with domain-driven design, and team organization with team topologies in order to design, build, and evolve adaptive socio-technical systems that are optimized for a fast flow of change. So let's start with an example and put these three perspectives together by evolving a legacy system. And we are using a fictitious example of an online school for junior students based on a legacy system, which is built, run, and supported by functional silo teams. To evolve our legacy system, we are starting with a team first, and we are starting to analyze their current situation in regards to team cognitive load and delivery bottlenecks. Due to handover, the functional silo teams reported about a high communication and coordination effort between teams when implementing and releasing changes. Dealing with a big ball of mud with a messy model and fuzzy boundaries leads to a high team cognitive load and tight change coupling. It takes a high amount of effort to understand a piece of code. And the teams also reported that there exist no clear ownership boundaries. So they were facing delivery bottlenecks impeding their software delivery performance. Due to on-premise infrastructure, the operational activities consist of configuration, backup and recovery mechanisms, maintenance, including upgrades and security updates, monitoring, scaling, and so on. So the infrastructure teams, they were facing high amount of operational efforts. But as a reminder from system thinking, if we are planning to locally optimize only separate parts of the system, that will not improve the performance of the whole. To improve the performance of the whole, we need to tackle the situation from a broader perspective and also understand the environment an organization is operating and competing in. That brings us to a Wardley map representing the landscape of an organization, and a Wardley map is part of Wardley Mapping. So who of you have heard of Wardley Mapping before? Few hands up there, so awesome. So you will learn today a lot about Wardley Mapping. So Wardley Mapping is a strategic framework invented by Simon Wardley, and it helps to design and evolve effective business strategies based on situational awareness and movement following a strategy cycle. And the strategy cycle is composed of 5 sections and is a representation of change and how we need to react to that change according to Simon Wardley. And it starts with the why of our business. Why are we doing what we are doing? In our case, our purpose is to provide high-quality education for junior students everywhere and help teachers to engage with their students online. The next section is the landscape an organization is operating and competing in, visualized with a Wardley map. So let's create a Wardley map of our current state of our online school. And a Wardley map is composed of a y-axis and an x-axis. The y-axis is representing the value chain. To derive a value chain, it starts with identifying your users first. Your users could be your customers, your shareholders, business partners, and internal users, and so on. In our case, we are focusing on the teachers and the junior students as the users of our online school example. Next step is identifying the user needs. The user needs, they are the problems that the users would like to get solved. And they represent the subject area for which we build a product. And in our case, the teachers would like to create course content or planning a class, helping students during their studies, evaluating the students' learning progress. The students would like to study in courses, requesting and receiving help, and also receiving evaluation feedback. And both need to sign up and sign in as well. And the users and the user need, they are representing the anchor of our map that all subsequent components relate to. The next step to derive the value chain is identifying the components that are fulfilling the user needs either directly or indirectly by facilitating other components in that value chain, and determining their dependencies and position of the value chain. So at the top, we have those components where your users are interacting with your system directly, where the components are located that are most visible to your system, and at the bottom it gets more and more invisible to the users. And the value to the users and the visibility, they are closely correlated. So the more visible a component is, the more value it provides to the users. In our case, the teachers and the students, they are interacting directly with an online school component, which is located at the top of our value chain. And at this moment, at this current stage, we are representing the online school component as a big ball of mud, as a single component that we are going to decompose later when we come to the second perspective of domain-driven design. And this online school component is depending on other components. For example, infrastructure components, such as data storage, search engine, message broker, SMTP service, compute platform, which is running on top of a virtual machine component. So they are less visible and they are placed further down the value chain. The next step to create a Wardley map is to take these components that you have identified and plot them along an evolution axis, going from left to right. So at the left, we have Genesis with brand new things, then custom build, then product and rental, such as off-the-shelf products or open source software solutions, and commodity and utility on the right. And to determine the evolution stage per component, let's look at some climatic patterns that are impacting our landscape. So that's where we come to the next section of the Wardley map or the strategy cycle, the climate. The describes external forces and rules that are impacting our landscape over which we have no control. However, understanding climatic patterns gives us an idea where the landscape might change, according to Simon Wardley. Understanding the climatic patterns gives us an idea where the landscape might change and where to invest in the future. Simon Wardley has compiled a collection of roughly 30 climatic patterns. No worries, we are not going through all of them. One of the climatic patterns is that the landscape is very dynamic and not static at all. So everything evolves from left to right through the forces of demand and supply competition. For example, cloud-hosted services are reflecting this climatic pattern of everything evolves through the forces of demand and supply competition. What was decades ago non-existent evolved through genesis, custom built, and became product and rental, and now commodity and utility. And while the components evolve through the evolution stages, their characteristics changes. So at the left, we have those components that are constantly changing, that are chaotic, that are unpredictable, poorly understood. And while it evolves through the evolution stages, it becomes more and more mature and more stable, where we are then dealing with a mature, known, well understood, commonly understood ordered domain. And we can use these characteristics to determine the stage of evolution per component. So let's go back to our online school example. And our online school component itself is reflecting a volatile, constantly changing component, providing competitive advantage. So that can go into the custom-built evolution stage. And the more stable, widespread, well-understood infrastructure components can go then in product and rental or commodity and utility evolution stage. And we can use appropriate methods per evolution stage. There we come to the next section of the strategy cycle, the doctrine. Doctrine describes universal principles that are applicable for every industries, regardless of their context. And applying these doctrinal principles enables an organization to deal with changes, to be able to respond to changes quickly, to be able to absorb changes gracefully. So one of the structural principles, Simon Wardley has also derived roughly 40 different doctrinal principles. We are not covering all of them, just only a few. So one of the doctrinal principles is using appropriate methods per evolution stage. This means to build components in Genesis and custom build in-house with preferably agile methods, to use or buy off-the-shelf products or using open source software solutions for component and product and rental, or outsource components in commodity to utility suppliers or using Six Sigma methods. Coming back to our online school example, so we are developing our online school component in-house with preferably agile methods. We are using open source software solution at the current state for our infrastructure components, such as data storage, search engine, message broker, and so on. And and the virtual machine component is currently at the current stage provided by a service hoster provider as an off-the-shelf product. Besides using appropriate methods, there are also other doctrinal principles, such as we need to know our users. It's very crucial for business to know their users, and we need to focus on the user needs in order to build the right thing. We need to know the details in terms of what is necessary to fulfill the user needs in order to generate value to our customers. And we need to use a common language to communicate effectively, specifically, particularly if you want to move fast in one direction as a team. And we need to challenge assumptions in order to create a better map, in order to create a better understanding of the landscape and of your domain. We need to break our landscape into smaller contracts and use small teams. We need to provide mastery, purpose, and autonomy. We need to optimize flow in terms of increasing throughput and eliminate delivery bottlenecks. And we need to design our organization for constant evolution so that a change can ebb through our organization without constant restructuring. But let's go back now to the team's perspective again. To optimize for fast flow of change from a team perspective, we need to avoid functional silo teams with handover. Instead, we need to aim for cross-functional autonomous teams that are responsible for designing, developing, testing, deploying their systems they are responsible for. We need to avoid handover so that work is never handed off to another team. We should aim for small, long-lived teams as the norm. The teams need to own the system or subsystem they are responsible for. They need to have end-to-end responsibility to achieve fast flow. We need to reduce the team's cognitive load, because if the team's cognitive load is largely exceeded, it results into a delivery bottleneck with software quality issues or quality issues in general, and also delays. And while a communication within a team is highly desired, we need to reduce an ongoing high communication and coordination effort between teams to enable fast flow of changes. And that's where team topologies comes in, with the well-defined team types and the well-defined interaction modes. So who of you have heard of team topologies before? A few hands are up, awesome. So, as I said, team topologies comes with well-defined team types and well-defined interaction modes. And one of them are the cross-functional autonomous streamlined teams that are aligned to a continuous stream of work and focusing on a fast flow of changes. To be able to focus on a fast flow of changes and to be able to produce a steady flow of feature deliveries, it needs the support from other team types. For example, it needs the support from the platform teams that are responsible for a platform which usually abstracts away infrastructure, networking, cross-cutting capabilities. And they are providing then platform as a service to the streamlined teams that the streamlined teams can then easily consume. Or they can get support from the enabling team, supporting the streamlined teams to acquire missing capabilities. Or they can get support from the complicated subsystem teams as an optional team type that support the streamlined teams on a particularly complicated subsystem which require a very specialized knowledge. And all of these team types aim to increase the autonomy of the streamlined teams and to reduce the cognitive load of the streamlined teams to, in the end, enable a fast flow of change. But arranging those teams and these team types is not enough to become effective. How these teams are interacting with each other and when to change or evolve the team interaction is also very crucial for organizational effectiveness. So team topology suggests 3 different interaction modes. One is collaboration, where teams are closely collaborating or working together with each other, aiming for a common goal. And it's suitable for rapid discovery and innovation, and where you would like to explore, for example, new technology stacks together. Another interaction mode is X as a service, and this suits well when one team would benefit or need a code library, a component, a platform, an API that could be effectively provided by another team as a service, and it works well where predictable delivery is needed. The third interaction mode is facilitation, and when one team could benefit from active help of another team, then facilitation comes into play. And this is a very typical interaction mode for enabling teams. And the combination of this well-defined team types and this well-defined interaction modes, they promote organizational effectiveness and also help to apply Wardley's doctrinal principles. So while Wardley Mapping suggests what principles to apply, team topologies and later on also domain-driven design helps us to how apply them. So let's start for architecting for flow. And that brings us back to our Wardley map that we use as a foundation for future discussions how to optimize our system for fast flow of change. So let's go back to our previously created Wardley map of our online school example. Architecting for flow or optimizing a system for flow requires to know where the most important changes in our system occur, the stream of changes. And the type of streams can vary from task, role, activity, customer segment, geography-related stream types. In our case, we are focusing on the activity streams represented by the user needs of our Wardley map. So creating course content, planning a class, helping students, they are good candidates for stream types, for streams of changes. And they need to be focused on when we want to optimize our system for fast flow of change. Then we also need to address or understand the problem domain and partitioning it into smaller parts. And while the users and the user needs are representing the anchor of our map, they also constitute the problem domain in the context of domain-driven design. There we come now to the other perspective of domain-driven design, which suggests to build software based on domain models first proposed by Eric Evans. So who of you have read the book of Eric Evans? Please keep your hand up to the end. Because it took me more than 4 times to start over again, start over again, start over again. So it's a very wise book, but for me it took a while. So, and domain-driven design comes with the core statement: in order to build better software, we need to align the software design with the business domain, with the business needs and the business strategies. And while we are applying domain-driven design, it helps us also to apply some of the doctrinal principles of Wardley mapping. And domain-driven design comes with patterns and practices of strategic and tactical design. So in the problem space of strategic design, that's where we are analyzing our problem domain and distilling the problem domain into smaller parts and the subdomains. And not all subdomains are equal. Some are more valuable to the business than others. So we have different types of subdomains, such as core, supporting, and generic. The core domain, that is the essential part of our problem domain, providing competitive advantage. It should be hard for competitors to copy or imitate. It tends to be quite complex. It changes very frequently. And this is the part of our system that we need to strategically invest in most. That's the part of our system we should build in-house. So the core domain usually goes then into the genesis or custom build evolution stage. The supporting subdomain supports the core domain. It does not provide competitive advantage. Businesses cannot work without them. They are quite simple. They change less frequently than the core domain, and we should look out for buying or using off-the-shelf products or using open source software solutions if that is not possible. And if we need to custom build the supporting subdomain, we should not invest heavily in that part of the system because it does not provide competitive advantage. The generic subdomain, these are subdomains that many business systems have, such as authentication, payment, and so on. So they are not core. They provide no competitive advantage, but businesses could not work without them. So they are generally complex, but already solved by someone else. They tend to be quite stable, and we should apply using or buying off-the-shelf products or using open source software solution. Then it goes in product rental or outsourcing to utility suppliers and commodity and utility for this part of the software. Coming back to our online school example, the course content creation, planning a class, learning support, and studying courses, they might fall into the resort of our core domain, providing competitive advantage. leading to a high level of differentiation. So they embody a high level of complexity, tend to change very often, and are less widespread in other business systems because that's our differentiator. So the strategic investment should be high for this part of the software. The evaluation of student and learning progress could fall into the supporting subdomain, not providing competitive advantage, but supporting the teacher's experience and requires to be available for the organization to succeed. They are less complex and change less frequently, and we should not invest too much into that part of the system. Signing up and signing in, they relate to the generic subdomains. So authentication and registration, they are widespread, extended, and expected in other business systems as well, leading to a high level of ubiquity and a high level of stability. And so they change less frequently, but there exist several solutions on the market already, and we should not strategically invest in that part of the system. So there's no need for innovation here. So we're already in the problem space where we discover and understand the problem domain. Now we're switching to the solution space of strategic design, of domain-driven design. That's where we are decomposing our monolithic big ball of mud into modular components, the bounded contexts. A bounded context defines where a single model lives in, where a single domain model can be applied. And a domain model reflects the business logic of a specific area of our system. And a domain model forms a unit of mastery, purpose, and autonomy. And a bounded context itself also reflects themes where we can split our system apart, but also suits well as different boundary types. For example, ownership boundaries that we address in a little second. Designing bounded contexts and domain models involves a close collaboration between the domain experts and the development teams to gain a shared understanding of your domain. And there exist several techniques to design them, such as event storming, domain storytelling, example mapping, user story mapping, and so on, that you can also use them complementary. They are not mutually exclusive. In our case, we designed the bounded contexts of content creation, course studies, class management, and learning support. They fulfill the user needs of our core domains. They should be built in-house. The bounded context of student evaluation and notification handling, they are related to supporting subdomains. And there might exist solutions on the market already. However, the team decided to custom build it. So it goes also in the custom build in this example, but we should not invest too heavily in that part of the system. Identity and access is the bounded context that fulfill the generic subdomains and could go in product and rental or commodity and utility. Another step to architect for flow is to find suitable team boundaries, and there we come back to our bounded context that we have designed before, forming that we can use as good suitable team boundaries for our stream-aligned teams, providing purpose, mastery, and autonomy. And to architect for flow, we also need to optimize for team cognitive load, if you remember what I said in the beginning. And we need to optimize for fast flow of change, or to optimize for team cognitive load, we need to limit the number, the type, and the size of components or bounded contexts a single team can own. And this brings us back to the characteristics of the evolution stages. The more left a bounded context or component is located on our Wardley map, the higher the level of uncertainty is. A component in Genesis is changing far more frequently than a component in commodity and utility. For components in commodity and utility, we can draw on best practices leading to a clear path to action. And we can also apply different practices for the evolution stages related to their path to action from best, good, emerging, novel practices. And the more unclear, when you go to the left side of the Wardley map, the more unclear the path to action is, the higher the cognitive load of a team might be. So that means that a single team can own more or larger components residing in the right spectrum of our Wardley map than residing on the left spectrum of our Wardley map. Another aspect to optimize for team cognitive load is to create clear ownership boundaries. That means that a single bounded context should be assigned to a single team only. We should not share bounded contexts across teams because that would diffuse the ownership. However, one team can own several bounded contexts. Another aspect to architect for flow is to identify services that are needed to support a reliable flow of changes. And so the streamlined teams that are focusing on a fast flow of changes, they need platform teams to provide a platform as a service that the streamlined teams can then easily consume. And this platform that the platform teams are responsible for should aim for a thinnest viable platform, so that it's just big enough to fulfill the user needs of their consumers and not become larger than needed. And it could start with documentation, with standards, with templates, and could evolve later into a digital platform with self-service services and APIs and tools. We also need to architect for flow, we also need to mind dependencies and communication bandwidth between teams. So if teams are constantly communicating, coordinating between each other in order to implement and release changes, then we need to eliminate this. And we also need to identify capability gaps of teams. That's where then the enabling teams come in to acquire missing capabilities. So these considerations can lead to this possible team constellation. So the most teams types that you see in organizations could be then the streamlined teams. In our case, we have the 4 core domain-related bounded contexts that are going to be taken care of 3 streamlined teams. The supporting and generic subdomain-related bounded contexts are going to be handled by another streamlined team. And the infrastructure and platform-related bounded contexts are going to be owned by 1 or more platform teams. But before we are going into the transition phase, we also need to mind potential efficiency gaps. We want to avoid building or evolving our system based on inefficiencies, because inefficiencies are also impeding our fast flow of change. So for example, and that's also where the Wardley map comes in, if we are using components in our organization that are less evolved than the components that are available in the market, we might encounter efficiency gaps. For example, if we are using components in custom build, but these components are available as utility in the market, then we are lagging behind, and we might indicate or might encounter inefficiencies. And the larger the gap, the less efficient the organization might be. So we need to close efficiency gaps to evolve our system. And in our case, we are planning to migrate infrastructure components to cloud-hosted services in a second. So far, we have not transitioned anything yet. So we have just designed and architect for flow. We have not touched any code yet. We have not reorganized anything yet. How do we go from A to B? And this is something where we do a team-first approach instead of technology-first approach. We do a team-first approach through dynamic reteaming and an evolution of team topologies interaction modes, supporting a cloud migration and executing a cloud migration strategy. Since we would like to evolve our system on we would like to close our potential efficiency gap to eliminate our inefficiencies, we are focusing on the infrastructure and platform-related components first. And since we are focusing on the infrastructure components first, we are forming the platform team first from members of the previous back-end and infrastructure teams. And we are, and this platform team is then formed on a site with the freedom to learn, explore, and discover cloud migration strategies, and also assess cloud migration strategies, determining a migration plan, and also determining the new platform. So in our case, the platform team decided to start with a replatforming strategy. With replatforming, we are replacing on-premise infrastructures with cloud-hosted services and modifying the underlying infrastructure while we keep our applications architecture the same. And we can do this incrementally, step by step, so that at the end we have incrementally moved our on-premise infrastructure to cloud-hosted services so that we can also offload our initial operational efforts to the cloud provider and offload the management of the infrastructure component to the cloud provider and close our previously encountered and analyzed efficiency gaps. As soon as the infrastructure has been migrated to the cloud, the remaining infrastructure team can merge into the platform team as one single team, and from there they can also split in different teams later on if this is applicable. So far we have replatformed our infrastructure to the cloud-hosted services, but we also want to modernize our big ball of mud to eliminate the delivery bottlenecks or the bottlenecks in general. And there we come to the next cloud migration strategy of refactoring. And our teams would like to refactor our big ball of mud and incrementally decompose it into the bounded context that we have designed before using domain-driven design. And with refactoring and the application architecture, we are splitting apart our big ball of mud into smaller parts and changing the application's architecture. And we are forming then, to kick off the refactoring journey, we are next doing a team-first approach and forming the first streamline teams, kicking off the refactoring journeys from members of the previous front-end and previous back-end teams. And in the meantime, also the front-end and back-end teams are merging together that then take care of the remaining monoliths as long as it exists, as one team with no handover involved, as a temporary team that is going to be split then later on into separate streamline teams. Let's go back to the first form streamline team. So this one is getting active support from the previous platform team that having a close collaboration between the first form platform team and closely collaborating with the streamline teams to jointly discover and assess cloud options for the future bounded context that the new streamline team is going to be responsible for. The new streamline teams might decide to refactor their bounded context using serverless technologies. As soon as the potential cloud options has been discovered, their close collaboration can go into limited collaboration, and where they go from daily to occasional on-demand collaboration and facilitation mode. And as soon as the serverless ecosystem is more established in the organization, at a later stage, the platform team can go provide a platform as a service, so the collaboration goes then into X as a service, where the platform team can provide best practices, standards, tools, APIs, and so on. The next step is then to refactor to extract the next bounded context, where we are forming then, splitting then the next streamline team from the merged team. And they get active support from the first form platform team and the first form streamline team. So the platform team can also assess possible cloud options for the future bounded contexts of the new streamline teams. It could also coach, for example, the new CI/CD pipeline how to use this in the serverless ecosystem. It could also point to the previously established platform as a service that then can incorporate their feedback while they're using it. The first Streamline team can coach the new Streamline teams, for example, about sharing their knowledge, and can coach them about how to implement serverless function in a hexagonal architecture, for example, so that the new Streamline teams can then refactor their bounded contexts. And from there, the next Streamline teams go on their cloud journey, decomposing their bounded context, also receive, again, facilitation, support from the other team types during their cloud journey, so that at the end, we can decompose our big ball of mud, our monolithic big ball of mud, into modular bounded contexts, and can modernize our system for fast flow of change. So that we have then achieved to remove our functional siloed teams with handover and evolve them into well-defined team types and well-defined interaction modes of team topologies. We are able then at this moment to restrict a high communication and coordination effort between teams. We could decompose our monolithic big ball of mud with a messy model and fuzzy boundary into a system with clearly defined models and clearly defined bounded contexts. And with bounded contexts, we can establish clear team ownership boundaries. We move from a tight change-coupled system into a loosely coupled system, and we could also optimize for team cognitive load. We could eliminate our bottlenecks, delivery bottlenecks, and increase our software delivery performance. And with moving to the cloud-hosted services, we offload the management of infrastructure components to cloud providers and reduce our operational efforts, and could close our efficiency gap. So I come to the end. So the combination of Wardley Mapping, domain-driven design, and team topologies helps us to understand the environment an organization is operating and competing in. It helps us to gain domain knowledge and discovering the core providing competitive advantage. It helps us to know what components to build in-house, where to buy or use off-the-shelf products or use open-source software solutions, and where to outsource to utility suppliers. It helps us to decompose our problem domain into modular components and designing the bounded contexts. It helps us to align our teams and evolve their interactions to the system that we build and the strategy we plan. It helps us to identify potential efficiency gaps and eliminate bottlenecks and increasing our software delivery performance, so that we are then at the end able to respond to changes quickly and to absorb changes gracefully. So the combination of Wardley Mapping, domain-driven design, and team topologies provides a holistic, powerful tool set to design and build and evolve adaptive socio-technical systems that are optimized for fast flow of change with a focus on improving the system as a whole. And with that, I've also put some references on them, so there are far more. This is a small extract of it. And if you are interested in more details, how to connect more dots, because I just left out so many other parts of the system that did not fit into this talk. So there is coming a book soon-ish. And with that, I thank you so much for your attention. I'm looking forward to your questions.